Hello, this is the second part of soft skill and data science project cycle section. Now let's continue with common pitfalls of data science project. Based on the data science project cycles, we can see there are problems from different kind of stage. At the problem formulation stage, one of the biggest problem is actually solving the wrong problem. It sounds funny, but due to the weak description of the business needs and misalignment across many teams, and more importantly, data scientists are not involved in the initial discussion of the problem formulation, solving the wrong problem become very often in industry. Overpromise on business value. Everybody wants to have a great return for the data scientist team and data science project. And oftentimes, people have unrealistic high expectations. And assumptions are ignored, and assumptions are sometimes way off chart. And data scientists usually have a data-driven and fact-based voice, but oftentimes their voice are not heard when the business value definition is put on the table at the beginning. At the project planning stage, too optimistic about the timeline. Project management team usually does not have the past experience about data science related project. There are many uncertainties are not counted at the planning stage, but actually those uncertainties should be counted, such as the amount of work or time needed for data pre-processing, for example. And it is fundamentally different from other projects. So that's actually because of the difference, it is very often to have a too optimistic timeline about a data science project. Too optimistic about the data availability and quality. Even though there are huge amount of data, the size of the data is very large, but a big data is not a guarantee of good and relevant data. In most of the problems, the ideal data for the business problem is not available. And at the most, there's some relevant data, but not ideal. There are unexpected efforts to bring in the right data. At the modeling stage, we're actually more familiar with the pitfalls in the modeling stage, like unrepresentative data, biased data. And too optimistic about pre-processing and feature engineering, and overfitting and obsession for complicated models. So with a lot of data and a lot of features, it is easy to get overfitting. And we have to make sure the model is actually going to work on the real-time application, not only work on the training or testing data set. Take too long to fail. During the modeling stage, we didn't see the expected result, and there are always requests for more data. There's always requests more features and more complicated models. But sometimes, if the project's direction is wrong, it is better to fail the project early, such that all the resources can be put into a more successful project in the future. In the productionization stage, fail to scale in real-time applications, maybe due to computation capacity, data storage, and latency constraints, and maybe not enough engineering resources are allocated to scale the model in real-time applications. Missing necessary checkup, lack model monitoring, and there's lack model tuning, retraining, and retirement plans. Once the model is put into production, we need a constant monitoring and a well-defined plan for tuning, retraining, and retirement. Bad production performance. Sometimes if we do not have A/B testing or shadow mode for the model and put the model directly into production, it is very likely we're going to see bad performance. And the data availability and stability in real time is also a big problem for production performance. Now, let's focus on the soft skills. As a statistician, we have a pretty strong modeling background as well as a pretty good sense about the data. So with our knowledge, we should lead the project from the beginning of the cycle. We should keep a high standard with data-driven and model-backed decision-making process. We should clearly communicate potential issues of the project as well as providing proactive suggestions. So which is extremely important because we know the importance of the size of the data, the relevancy of the data for the business problem. And oftentimes we see it is not good enough, it's not large enough. So simply saying no, it's not going to work. It's not going to give us the reputation. And alternatively, once we know it is not going to work, we have to provide an alternative or a way to work. So a proactive suggestion of a working plan is more important than just saying it doesn't work. And as a statistician, we usually have the bad image of like gatekeeper of like we always say it's not working. But more importantly, we should find an alternative to make it work. For communication part, as a data scientist, we're working with all different kind of teams, so we have to speak the same language with different team members. Like for example, label, target, outcome, class, response, dependent variables. They're all called different names by different kind of people from different background, but those all means the typical Y variable. Features, attributes, independent variables, predictors, covariates, those are different names for X variables. Like weights and parameter, learning and feeding, generalization and applying to the population or testing data. Those are actually the terminologies used by different group of people. As a data scientist, we have to learn to speak other people's language. Now look at the different styles of communication between statistics and data science. For example, in statistics, we have all kind of errors, type 1 error, type 2 error, mean square error. For data science, people usually use accuracy and precision. They're the same thing, but it sounds like a better choice in data science using accuracy and precision. And in statistics, we have dummy variables, lack of fit, and loss functions. In data science, people are using like one-hot encoding, faithfulness, information gain. It's just it is not like one-to-one mapping between the left and the right, but it's actually gave us a common kind of theme or sentiment between statistics terminologies and data science terminologies. So the list can go on and on. So basically, as a data scientist, sometimes we need to communicate with kind of right type of terminology to attract attention from all teams. So those are related to technical skills and soft skills. There easily transferable actually from one business sector to another. So those are actually an advantage for data scientist career. But business domain knowledge usually learned during work is actually very similar to statistical consulting project. And many of our statisticians are actually consultant. So we do know how to understand the business domain knowledge. And job shadowing with um, office and field agent for a new domain is actually very helpful to know the pinpoint for a particular business, and as well as understand how the data are actually collected. So those are different kind of ways to keep a data scientist career. And at the end, there's a very fun video called The Experts. So it is hilarious, but sadly true for many data science projects. Probably you are the only data scientist in the room next time. So be prepared to fight back in the same scenarios as shown in this fun video. Thanks. That is the end of this section.